All right, let's tackle with part B, and that is the integral of 2e to the minus x cosine hyperbolic x from the lower limit 0, upper limit ln2. Another observation here is that 2 times e to the x, e to the minus x, cosine hyperbolic x is a non-negative function. And if you integrate it from 0 to ln2, that corresponds to the area between the graph of 2e to the minus x cosine hyperbolic x and the x-axis stuck in between 0 and ln2. And go ahead and use your TI-84 if you want to just to see what kind of like area or region we were talking about. So here we go. So I just graphed it for you. So the blue curve is the curve of 2e to the minus x cosine hyperbolic x, and the bottom is x-axis. And we're interested in the area in between 0 and ln2 for x's, right? So we're talking about this region here, okay? And the area of this region is just this definite integral. So whatever the value we come up with is going to be this area of the region. All right. So now let's start thinking about how we can integrate this integrand. And as always, I'm going to write indefinite integral version of the same integral to see how I'm going to treat this part first. Okay. And please, you can pause the video at this moment and start thinking about what you can apply or what kind of like technique you're going to use to integrate this integral. Please do it. So one thing that you may need at this moment is the definition of cosine hyperbolic x, because we know that hyperbolic functions are defined in terms of exponential functions. So you have exponential function against a hyperbolic function. So why don't we look at the definition of cosine hyperbolic x to start with. And you have the table for the definitions of hyperbolic functions, and you're staring at the definition of cosine hyperbolic x. That's e to the x plus e to the minus x over 2. So going back to here, let me just spend a little time here to simplify the integrand. Okay, e to the x plus e to the minus x over 2. Okay. Well, if we expand this through, so you have e to the x, e to the minus x times e to the x plus e to the minus x times e to the minus x over 2. Okay. And then this is equal to, well, e to the minus x times e to the x is 1. So 1 plus e to the minus 2x divided by 2. So this whole integrand here, can be replaced by 1/2 1 plus e to the minus 2x. So how awesome, right? Because this 1/2 is going to cancel out the 2 outside. So this integral is going to look like just the integral of 1 plus e to the minus 2x dx. Okay? So this is us using the power of the definition of cosine hyperbolic x written in terms of exponential functions. Okay? So this is two integrals, 1 dx plus e to the minus 2x dx. And you can even integrate everything in one shot. So this is x plus, you may have like a quick u substitution here, u equals negative x, and on a scratch paper, and to get to the conclusion that this integral is taking you to minus 1/2 e to the minus 2x and plus the integrating constant. Okay, so again, we have this result right now, and towards the calculation of the definite integral, I don't need to carry forward the integrating constant. So I'm going to go ahead and write this integral as x minus 1/2 e to the minus 2x, and lower limit is 0, upper limit is ln2. Okay? So I'm going to write down the upper limit first. I'm going to plug that in first. ln2 1/2 e to the minus 2 ln2 minus 0 minus 1/2 e to the minus 2, 0. Okay? All right, so first observation here is that this term here is a very special term. You can always use your calculator, but again, we're always trying to get the exact value, so you should sort of know this property here. And then maybe not necessarily for this question only, but for future questions as well. So let me just write that here. So I'm going to put this -2 as an exponent of 2 in ln, right? That's one property of ln that I'm using here. So it's 2 to the minus 2. But 2 to the minus 2 is 1/4. And e to the ln of a number is always equal to that number. So I'm using like multiple properties here, and I want you to sort of like practice this by yourself and make sure like those properties exist and we do apply them. Okay, so that term here is equal to 1/4. So I'm going to erase this and continue there. Okay, here we go. So it's ln2 minus 1/2 times 1/4 minus 0 times 1/2 e to the 0, which is 1. So minus 1/2 of that is minus 1/2. So it's plus 1/2. Okay. All right. So what do we have? ln2 minus 1/8 plus 1/2. Okay. You simplify that, it's ln2 plus 3/8. Okay. If you wish, now you can use your calculator and get an approximate value, or just leave the final answer as is. And we do know that this area of the green region is represented by the output of that definite integral, which is ln2 plus 3/8. And again, in this question, we were not asked anything about the area or something, but I just wanted you to sort of like compare this indefinite integral calculation to the area calculation, because at the end of the day, you are going through this calculation to find that area. Okay, so you're going to go through this definite integral calculation towards finding that area, if the question was asking about the area between the curve and the x-axis. Okay. Anyway, so this takes care of part A, or part B even, right? So we're done with part B. I think that ends the whole video and whole exercise. So, all right, thanks for watching. And if you have any questions or comments or even suggestions, please send those to my way. All right, bye.